there are 3-point charges here. We have Q1, Q2, and Q3. And as you can see, Q1 and Q2 are positive and Q3 is negative. And the question is, what is the net electrostatic force exerted on the point charge Q1? So we are worried about Q1 and not about the other two. So what we would like to do is draw a little box or a circle around Q1, and we are going to draw our arrows, our directions inside this circle. So let's look at Q1 and Q2. Now they are both positive, meaning they repel. So at Q1 it's going to repel Q2. So we are going to draw the arrow like that, and this is our F1, 2. Note that Q2 also has a direction for this force, but we don't care about it because that's not the question. And then now let's look at Q1 and Q3. And when you look at Q1 and Q3, you see that they attract because it is positive and negative. So we are looking at inside this area. So at Q1, it's going to attract towards Q3, and we name it F1 because of 3. So F1, 3. So those two are our angles, our vectors. Now let's look at the angles a little bit. So if you extend this, you see that, so this is a 60-degree angle. And because that's a 60-degree angle, this also becomes 60 degrees. So that is important when we look at components. So now let's find out the values or the magnitudes of F12 and F13. So we have F12. So we have K, Q1, Q2 over R squared. Okay, which is 8.99 times 10 to the 9th. And I'm not going to write down the units here. And then we have 2.1 times 10 to the negative 6, because micro here is it's microcoulombs, that is 10 to the negative 6. And then we have 6.3 times 10 to the negative 6 coulombs, and then divided by the distance between 1 and 2. So we have to find out the distance between 1 and 2, and it's given by distance d. So you see that it says d here. So that's our distance, and we need to convert it into meters. So we need to divide 4.35 by 100. So that gives you 0.435, and that is squared. So we have this squared, and this is in meters. And that is about 62.85 newtons. So this is the magnitude, or the number, or how big is this number in newtons, is 62.85. Now similarly, let's find F13. So we have K, Q1, Q3 divided by R squared. So we have 8.99 times 10 to the 9th. We have 2.1 times 10 to the negative 6. And we only take the absolute value, which means the positive value. So 0.89 times 10 to the negative 6 is in coulombs, and divided by the distance between 1 and 3, and it is d here. So we have again 0.0325 meters, and that is squared, and that gives us 9.0 newtons. So these are the values for F12 and F13. But we need to find out the magnitude and direction of the net. So these are individual components here. So it's F12 and F13. Now let's draw a chart. star chart. So let's see, we have force, we have two forces here, and I want to look at x component and y component separately. So now this has just become a vectors question. We have two forces, we have F12, we have F13, and F12, you see that it is in the third quadrant here, so our x and y components are both negative, and the x component is right here. This is the x component, because if you look at this triangle here, this is our x component, so that is minus F12, and that becomes cosine of 60, or you can also write it as sine of 30. And then y component is also negative, and it is F12 sine of 60 degrees. So that would be this part right here, and see that it is negative. Now let's look at F13. You see that F13 is on the x. So what are we doing here is that we are looking at this as our y, and then this here as our x. So you see that F13 is completely on our x axis, so that is positive F13. I'm not plugging in values yet. And then we have 0 for the y component. Now if you remember from vector addition, what we do is we add all the x components, then we add all the y components. So let's just add the x and the y components. So we have negative F12. So F12 we figured out earlier here that it is 62.85, and that is cosine 60 plus F13, which is 9. And on the y we have negative F12, 62.85 sine of 60. So once we figure out our total x and total y, so this is the sum of x. So this part right here gives us the fx, and this part here gives us the fy components. So once you have that, what we can do is to figure out the angle. And before that, let me write down the numbers here. So if you calculate this x value, it's going to be 22.49. It's going to be a negative n. And then for y, this is going to be negative 54.43 n. So that is our x and y components. And then what we can find out is the net force. So F net would be, so x component squared, y component squared, and take the square root of it from the Pythagorean theorem. So what we have is negative 22.42 squared plus negative 54.43 squared, and you take the square root of this entire thing, and that is in newtons. And then we have to find the direction, because we have to find direction and magnitude. So this would be the magnitude, and you can figure out what this number is by plugging it into your calculator. Now let's look at the direction. So let's draw an x and y again and see where these fx and fy fall. So you see that fx is negative, so it is negative, and this number is 22.42. And then let's look at fy, which is negative. So I go from the origin to the left and then downward, and that would be 54.43, and this would be my vector. This is my f vector from start to stop. So the magnitude of this number is what you get from the f net here, but we can also find out what this angle is. So we can use, for that we can use tangent. we had tan theta, which is equal to the opposite, so that is 54.43 divided by 22.42, and you do tan inverse of this value, and that should give you about 67.6 degrees, and that is this angle here. So if I were to find this angle from positive x-axis, so this is my positive x-axis counterclockwise, meaning if I start in the positive x-axis and go counterclockwise until I hit my f vector, then you see that it is theta plus 180, because you go from 180 and then theta. So the way I write it here is positive x counterclockwise would be 180 plus theta, and so that number would be 247.6 degrees. So that is the direction, and this is the magnitude.